Okay, so let's start our today's lecture. In previous lecture, we had picked several solutions to the critical section problem, and finally we have identified one solution that is known as Peterson's solution, uh, which satisfies all three conditions. That was mutual exclusion, progress, and bounded weighting. Now today we will move further and we will discuss a certain hardware-based solution. Now, earlier solution was purely based on the software. Now, can we restrict synchronization or can we restrict entering of process into critical section using specific hardware? So that is the overall point. So first solution regarding to hardware-based solution, that is disabling of interrupt. Now, what is disabling of interrupt? Disabling of interrupt says that what I can do, that if one process is executing in its critical section, then whenever that process will enter into the critical section, that is my entry point. Now here, what it will do, it will disable all interrupts. Now, as we all know that whenever any process wants to enter or perform anything, that process has to provide certain kind of signal, and that signal will be given on the basis of interrupts. So what I'll do, I'll disable all the interrupts. So no process will be able to give or request for anything, hence nobody can enter into the critical section. And whenever that process has completed its task in critical section, what it will do, it will enable all the interrupts. So in this way we can easily maintain the mutual exclusion property here. So that is the simplest solution with respect to the critical section, that is disable all the interrupts. So the thing is that is this solution is practically feasible. Now how you will identify that which particular interrupt is for which purpose? So what you have done, you had disabled all the interrupts. So suppose there are two processes P1, P2. P2 wants to enter into the critical section, hence you have disabled all the interrupts. But P1 wants to perform certain other task which is purely not related to this critical section. But because your operating system has disabled all the interrupts, then P1 will not execute at all. Hence, only one process at a time is in execution, irrespective you are having multiple copies of resources or you are having several resources. Only one process will run. Hence, multi-programming becomes absolute here. So that is the major point, that why we cannot disable all the interrupts. So practically this thing is not that much feasible. Yes, it is implementable, we can implement, but it's not feasible. It will not provide us fruitful answers or fruitful efficiency. So what is alternate solution? Alternate solution is certain hardware level of programming through which I can hold processes on hardware level, and that is using TSL, test and set lock. So how test and set lock works? So it's a very simple code. What I'll do, that whenever any process wants to enter into the TSL, it will run this, and because of these specific things, there will be certain lock which will get applied. Now how it works? So let's pick this thing. This is the code for any suppose P1 process. Now, whenever that process will arrive, the first thing says that while TSL lock. Now, if this value is returning true, then definitely what I am going to do? I am going to move here. Otherwise, I am going to move down. Why? Because there is one semicolon here. So, when we got TSL, it will move to its definition. And TSL says that move here, which says RV is equal to target, and at the start target is false. At the initial level target is false. So what it will do? It will become false. So RV becomes false and then target becomes true. And what you are returning here, you are returning RV. So RV will get returned, and when RV will get returned, that is value is false. So what happened? That it will provide me false, and hence because this loop becomes false, what happened? I'll move into the critical section, and after completion of critical section, what I'll do? I'll make that lock is equal to false, because whenever any other process P2 is arriving, that process will also run the same thing. So it will move into TSL lock. Since I am in critical section, so this code earlier got executed, so target becomes true. So here it will give true. So RV is true and target is true. So both are true. So return value will be true. Hence, this will be true, and all other processes will run into this indefinite loop or infinite loop. Up to what level? Up to this level, that whenever that process will go out, what it will do? It will make value false. And once you got lock false, one process will get chance for execution, and in this manner it can easily execute. So I hope you got the concept that how TSL works, and how by using simply TSL basic lock functioning, we can ensure the mutual exclusion in the system. Now here, for one thing you should be pretty sure that this particular thing will be run in atomic mode. Now, what is atomicity here? Atomicity means that at one instance of time, only one process will access this thing. No two processes can access parallelly this thing. Only one process will execute this thing, so that so that system can avoid the problem which we had picked earlier in producer consumer. So that is the major thing. So that is based solution based on test and set log. Now there is one alternate implementation of TSL, that is by using swap function. I hope everybody is aware with swap functioning, where two variable value of two variable gets swapped by using certain third temporary variable. We all have done such kind of code at the start of our coding, and that is like this one, that we have two variables. First value of first variable will be given to the temporary, then second variable value will be assigned to the A, and temporary value which we have earlier given A value to temp, that will be assigned to B. In this way we can swap the value of A and B. Now we are going to utilize this concept to deploy our TSL, test and set log. Now how we are going to deploy it? Let's check how to use it. This is the code of one process. Each and every process have its own key. Once again repeating, every process have its own key, and whenever any process wants to enter into the critical section, suppose there are three processes, P1, P2, P3, and these processes are sharing this critical section. So each process is having key 1, key 2 and key 3. Every process is having its own key. Lock remains same, but key is different for each and every process. Now what will happen whenever any process wants to enter into the critical section, it will make its key true. So this says that I want to enter into the critical section. So since you have made this, every process is going to declare it true. Let's move to the next state. Next state says that while key is true, which every process has made definitely, since it is true, what it will do? It will move into the swap function. And swap function says that it is having lock and key. That we know that key is true. And at the start, lock is false. So swap says that I have false value and I have true value. And since because of this swapping, what will happen? That lock become true and key become false. Now, this while is true, hence we move into this line, but this is inside while. So whenever this will perform its task, we need to again move to the next while loop until and unless that loop gets false. Then only we will move into the critical section. So because that particular K1 K1 has what done? K1 has made true, and since K1 has made true, move into the swap function, and swap function says that now lock will be true and key will be false. And once that P1 process will move again, key becomes false. Since key is false, it will move into the critical section. So P1 entered into the critical section. Now suppose P2 arrived. Now P2 is saying that key is true. They move into the lock, but lock is common. Here lock is common and lock is currently true. So true, true. That is for P2. And if both are true after swapping, they will be true and true again. Hence, whenever it will move further, key is again true. There is no change. So it will move infinite until and unless other process has leave the lock. So when that P1 process has completed its task, what it will do? It will make the lock false. And when it will make the lock false, any one process will get chance for swapping, and because of that swapping, that key of that particular process will become false and that process will get enter into the critical section. So in this way, that can be easily performed, that is TSL using test and set lock using swapping. So that is overall hardware based solution through which we can perform mutual exclusion quite effectively. So that is overall related to hardware based solution. Now in next class, we are going to pick one more kind of solution that is known as semaphore. And specifically, we are going to pick n process or n resource solution. Till now, whatever we have picked, that is n process solution. And now we are going to pick that if I am having suppose n number of resources, then how to make synchronization properly, and that thing by using the another variable, that is semaphore, which we will discuss in our next class. So that is all for this lecture. Thank you.